Lesson 2-2, limits involving infinity, also known as asymptotes. We don't use infinity in math, so this lesson is all BS to me, but I'm beholden to what they do in calculus. So let's see what we got, all right? So yeah, I like to point out that, things start to get more complicated. It's gonna be a theme this year. Uh, let's determine limits as we approach positive, negative infinity. Now there's two aspects to that. We can say as we approach infinity, or as the limit approaches infinity. We'll get into that in a second. So let's say we've got a graph, and you should have 1 over x memorized. If you don't, you're handicapping yourself, but do what you got to do. All right, so look carefully. What's the limit as x approaches infinity? What's the limit as x approaches negative infinity? Did you notice that? So limit x approaches infinity. We're heading out here on the x-axis. This is getting closer and closer to 0. Limit for the same function as x approaches negative infinity, also 0. So you've seen this before. Power on the bottom is bigger than the power on the top. It approaches 0. It was a rule we had from pre-calculus. We call it a horizontal asymptote. Probably not the worst idea to learn how to spell asymptote. So we define it, the line y equals b is if the infinity, yeah, whatever. It's a horizontal asymptote. Okay, we skipped the sandwich theorem, all right? And, it's something that they used to teach and then we never touch it again, so I get away from it. But here's one of the things they like to do is say, well, negative 1 over x is always going to be less than or equal to sine of x over x. So they're sandwiching this between, and as we know what the limit as we go to infinity is, therefore the limit is sine of x over x. Yeah, this is stupid. All right. I've asked people to have me draw this out so that they don't have to worry about it anymore. I should, but I'm just going to leave it in for now anyway. Since sine of x over x is always less than this and blah, 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 it's always between these two. By the way, you should plug in numbers, make sure I'm not lying to you. All right, now the reason we blow this off is because it's in between. Is because we're going to find a lot better ways to do limits as soon as we get a tool called the derivative. So hey, there's one more property that we didn't give you in the previous section. Limit of f of x to a power is, well, if the limit of f of x is L, then you can just put the RS out there. This is a, what kind of moment to me? I've never used this ever. So it always just freaks me out a little bit when they throw this at us. But let's get into this. All right, let's do this 2 different ways. All right. By the way, when in doubt, graph it. Read the full question. What is the limit going to? Because we'll gloss that and we'll say it's going to 0 and we run through and do the problem. Or we don't read the question. Hey, this one says it's going to infinity. All right. Now, here's what's going on. What dominates on the top? Sine of x just kind of waffles back and forth between 1 and negative 1. 5x gets freakishly big to infinity. So I could actually way number 1, just say, well, that's the same as the limit as x approaches infinity of 5x over x. X is canceled and just gives me 5. Or we could look at this and say, well, x can be broken into. This is a very, very classic, quote unquote, trick to solving problems. Well, I can take a common denominator and break it out, which we know is the same as the limit as x approaches infinity of 5x over x, plus the limit as x approaches infinity, sine of x over x, which is 5. This goes to 0 as we just proved. Careful, because limit as x goes to 0 is 1. That's not what's going on there. So be careful. Now notice, we might say, oh, I'll just apply the quotient rule. What's 1 go to is infinity and 5. Yeah, no, that doesn't work in this case. So just be careful. If we said that the top function was 5x plus sine x, and the bottom function was x, and then we said the limit as x approaches infinity of f of x is infinity. And the limit as x approaches infinity of g of x is infinity. And we'd say, well, hey, we get, that's wrong. And you might say, well, how the heck am I supposed to know that? Well, that's unit 9. We'll talk about infinity over infinity, how we can break it down into something else, but we don't have the tools for that yet. So soon enough. Okay, what about vertical asymptotes? All right, well, line's vertical asymptote if either limit as x goes to a to the positive side is plus or minus infinity, or limit as x goes to a from the negative side is positive infinity. So watch that positive and negative there. It's very small, very hard to see. All right, so find the vertical asymptotes. Describe behavior left and right of the vertical asymptote. So again, you should know this one. All right. So there's a vertical asymptote at x equals 0. You should know that from pre-calc. Well, I just set the denominator equal to 0. Okay. Well, the limit as x approaches 0 from the negative side, let's come here, of calling it f of x. I could just write in 1 over x squared equals positive infinity. We don't usually put the positive. I do it for now. I don't think it's a bad idea. And I love things in math that they do just to confuse you. As we go to from the right is also positive infinity. Notice it's not the same for 1 over x. You gotta go back in your notes, see what's going on. All right. All right, on the vertical asymptotes for tangent of x. So got to go deep into the memory bank here. I believe it comes up the middle and at pi over 2. 3 pi over 2. Negative pi over 2. Negative 3 pi over 2. Something like that. It does this. And so on and so on. It keeps going. All right. And we would say vertical asymptotes at x equals some k times pi over 2 and times negative 1, negative 2. No, that's not right. Yes, it is. Not negative 2, negative 3, 1, 3, 5, where k is all odd integers. K is all. That's a funky little, like I didn't finish making any, and you don't have to write it that way. You can write it any way you want. All right, and notice that from the left it's positive, from the right it's negative. You got to keep an eye on all that. All right, now this is boring stuff and it's not critical. They're going to talk about end behavior. They want you to think about how, again, this is all prepping you for unit 9, which is way down the road. All right. But the point they're trying to make is that this is the dominant part of the function of f of x, 3x to the fourth. So we would say that g of x, and we're going to say it down here, is the end behavior when x gets crazy large and either x going positive or x going negative. So if you were to graph these, you'd say, oh, look, this one's like this, and this one's like this. In other words, they fall right on top of each other because think about it, as we get freakishly big numbers, and this is what we're really working on here, is learning this concept of freakishly big numbers. These become irrelevant. When this becomes a billion, this becomes like a 10th decimal place. So this will dominate, and this is the same as the dominant one here. So you would say the end behavior, and I don't have to write end behavior as x goes to, that's what it means, as x goes to infinity or negative infinity. The only part of the function that matters is 3x to the fourth. All right, and that's what it's saying here. Function is right end behavior, and it's all that. All right, so find end behavior models for these two things. All right, and it's actually pretty easy. I don't know why I wrote that whole careful, you never know. So notice we're doing limit as x goes to positive and negative infinity. The 2x to the fifth is the biggest, 3x to the squared is the biggest, so we end up with 2, and we're going to call it f of x. Let's see if I can salvage this. That was horrible. F of x is 2x to the third over 3. Biggest power, just set up a ratio. Limit as x approaches plus or minus infinity. This f of x is biggest power on the bottom, biggest power on the top. They're the same, they cancel, 2/5. At which point you should be going, I don't know what's going on. So always graph it and see what's going on. Wow, if I put really big numbers in, I get y equals 2/5. So graph that. You should see that as you go out to infinity, it gets closer and closer to the asymptote of y equals 2/5. That's all we're saying. We're just getting you used to functions. You've actually done all this already in pre-calc. So we're just hammering it home. All right. And watch out with the whole positive negative thing. I don't know if I've seen this on an AP test. I've seen it on one of my tests. But you just got to be careful when you're going to positive or negative infinity because sometimes you think, oh, this is easy. It turns out it is easy. You just have to pay attention. So f of x equals x plus e to the negative x. All right, well, what's going on when the limit is to infinity? All right, what's the end behavior? Well, e to negative x, as x gets freakishly big, becomes 0. And if we were to graph this, this would look something like something like this. I'm not even going to bet my life on it. Or this is a straight line here. And this is a curved line. Actually, I should take off and go much higher. So this is y equals x, and this is y equals e to negative x. So you get just x. But if we're saying what's the limit as x goes to negative infinity, well, that's going to be e to the negative x. So just be aware. That's all. And then I actually used this to help the Calc 3 class out recently, which shocked me because they're smarter than me, and I just kind of feel like the junior man on the totem pole there in this particular case. But we can do this weird thing where they say, hey, let's say the function is sine of 1 over x, and I want to know what the limit as x approaches infinity of f of x is? Well, what we can do is change this infinity. Now think about it. 1 over infinity is 0. Sine of 0 is 0. But we got this cool little trick we can use. 1 over 0 is 0. So let's change this to x and change this to 0. It's weird. Now, of course, you got to worry about coming to 0 from both the positive and the negative sides. But let's say the limit as x approaches 0 from the positive side, a sine of, we change x with 1 over x, just gets us x. I'll write it out to make you happy. Equals the limit as x approaches 0 from the positive side of sine of x going to 0 equals 0. So this is a weird little trick. Change infinity to 0 and change the x to 1 over x. That's it. Just showing you a trick. I think it's neat. I think it's worth watching, learning. So as x goes to the negative side, oops, 0 to the negative side. Also equals 0. Cool stuff. Last but, no, that was last but not least. Yeah, it was pretty much least. So, little ticky-tacky stuff. People come out of this lesson are like, I'll never learn calculus. Yeah, just go do some problems. It'll be fine. It's not super hard. It's just ticky-tack. So good luck. Happy mathing.